This video is going to be on derivatives of trig functions and inverse trig functions. And the first thing that we're going to be doing is looking at how these derivatives came about, and then we will do some derivatives with those trig functions, applying the chain rule with those as well. So there are two main trig functions that you can build all the other trig functions from, and that is sine of x and cosine of x. So the first derivative we're going to approach is going to be the derivative of sine of x. Now, if you think about your derivatives at different places along your curve, this is your curve for sine of x. At maximums and minimums, you will have a derivative that is 0, because your horizontal tangent line will have a slope of 0. And so your derivative would be 0 at these two places right here. And if you kind of think about the slope at the different places, the slope right here of a tangent line, well, if you follow that up, it looks like that would be a slope of approximately 1. Over here, looks like you would have a slope of approximately -1. And over here, looks like you'd have a slope of approximately 1 again. Now, the way this works out, and you'll see it here in a second, is that this actually follows the curve going through these points right here. And this is cyclical or periodic, so it does continue forever in both directions. And what this does is graphs out the curve for the cosine function. And let's go ahead and take a look at this on Desmos. All right, so on here you can see the red curve is your sine function, and as we move this point, the red dot is what your derivative is actually going to be at the different x values as you move along. So you can see right here your derivative was 1, and then it follows along. You have a slope or a derivative of 0 right here. The green line is your tangent line. And then your slope or derivative becomes negative as your function is decreasing. And then you get a minimum value of -1 right here. And then it starts coming back up again. Still negative, but it's coming back up towards 0, and then turns positive once again. So if you follow this out, what you end up with is your cosine graph, and you can see it follows the cosine curve as we move this tangent line all throughout the sine curve. So what that tells us then is that the derivative of sine is equal to, you guessed it, cosine of x. All right, so the next one we're going to take a look at is what is the derivative of this. Okay, well, this is your cosine curve, and let's just go ahead and go straight to Desmos and get a pictorial for what this looks like. All right, so if you follow this along, this is your cosine curve, and then the blue dot is your derivative value. And so you're going to start out with the derivative of 0 here. It's going to go negative. You get a minimum value at pi over 2, and then it comes back up right here. And if you trace it a little bit faster, you can get a picture of this. Let me just go ahead and tie this to the curve. All right, so what you are doing is you are getting this blue graph for the derivative when you trace this out. You can see the derivative point following along that curve. Well, that blue curve is the opposite, or the reflection of the sine curve over the x-axis. So that means your derivative is going to be negative sine of x. So the derivative of cosine is equal to negative sine of x. All right, so now once we have a derivative for both sine and cosine, we can build all of our other derivatives from those two values. Keep in mind that tangent is equal to sine divided by cosine. And therefore, we can use quotient rule to find the derivative here. All right, so the derivative would be get this back here. The derivative would be if you take into account sine x over cosine x, the derivative is going to be bottom times derivative of the top, which is cosine x, minus top times derivative of the bottom, which is negative sine x, over cosine squared. All right, so that's going to give us cosine squared plus sine squared x over cosine squared x. And if you remember your identities from pre-calc, sine squared plus cosine squared is equal to 1. And 1 over cosine is equal to secant. Therefore, 1 over cosine squared would equal secant squared of x. So this is our derivative for tangent of x. All right, so now we're going to take a look at secant of x. Secant is equal to 1 over cosine of x. And if we again apply the power rule, I'm sorry, not power rule, quotient rule here, you're going to have bottom times derivative of the top minus top times derivative of the bottom over bottom squared. All right, so that's going to give us positive sine x over cosine squared x, and we could actually split this up to make it a little bit better. This is equal to 1 over cosine of x times sine of x over cosine of x, and 1 over cosine of x is equal to secant of x, and sine over cosine is equal to tangent. So this is what your derivative of secant of x is. It is equal to secant of x times tangent of x. All right, so the next one is going to be cosecant, and cosecant is equal to 1 over sine of x. So we're going to apply quotient rule once again. So you're going to have bottom times derivative of the top minus top times derivative of the bottom over bottom squared. And that's going to give us negative cosine x over sine squared x, and we can split this up kind of like we did before. This will give us negative 1 over sine of x times cosine x over sine x. Negative 1 over sine is negative cosecant x, and then cosine over sine is cotangent of x. So this is the derivative of cosecant of x. And then we have cotangent of x. So cotangent is equal to cosine divided by sine. And so we're going to use quotient rule here. So you're going to have bottom times derivative of the top minus top times derivative of the bottom over bottom squared. So you're going to get negative sine squared x minus cosine squared x over sine squared x. In the numerator, you can factor a negative out of both terms, which would leave you with negative parenthesis sine squared plus cosine squared. I'm sure you can see where this is going now. This becomes negative 1 over sine squared, and 1 over sine is equal to cosecant, so this will be negative cosecant squared of x. That is your derivative of cotangent. So now you're going to have some derivatives of inverse trig functions. The most widely used ones are going to be tangent inverse and sine inverse on the AP exam. So those are the two that I'm going to focus on here. So if you have y is equal to the tangent inverse of u, which also can be written as y equals arc tan of u, that is just a different notation that can be used for inverse tangent. It means exactly the same thing. So y equals tangent inverse of u. You can move the tangent inverse to the left side of your equation by taking the tangent of both sides of your equation. So that means the left side becomes tangent of y, and tangent of tangent inverse cancels out, leaving you with just u. All right, so what that leads us to then is going to be u is equal to the tangent of y. So what we're going to do with this now is take our derivative of both sides of our equation. Remember that when you have an equation, it stays balanced as long as you do the same thing to both sides of your equation. And that's what we're going to do here. So with this, we're going to have the derivative of u with respect to x equals the derivative of tangent of y with respect to x. Now the derivative of y with respect to x, well, we know that the derivative of tangent is secant squared. So this becomes secant squared y dy dx. That's our chain rule part here, is times the derivative of this. So secant squared y dy dx. We are now going to solve for dy dx by moving secant squared over to the other side, and you move it to the other side by dividing it. So that will give us dy dx equals du dx divided by secant squared of y. Now here's a Pythagorean identity from your trig functions that says sine squared plus cosine squared is equal to 1, which means if we took every term and divided it by cosine squared of y, your equation would stay balanced, but it changes what it looks like. Sine squared divided by cosine squared is going to be tangent squared. Cosine squared divided by cosine squared is 1, and 1 divided by cosine squared is secant squared. So what we are going to do is we are going to replace secant squared in our denominator with this right here. All right, so what we get then is du dx over 1 plus tangent squared of y. Well, from up here we know that tangent of y is equal to u. Therefore, tangent squared would be equivalent to u squared. So that gives us our derivative of tangent inverse, which is tangent inverse of u is equal to the derivative of u over 1 plus u squared. And we'll see how this applies in a little while. Over here what we have is your graph of your tangent inverse function. And over here, this is our graph of our sine inverse function between -1 and +1. And we derived the formula in a very similar fashion. First thing we did was take sine over to the other side, making it sine of y is equal to u. Taking the derivative of both sides of our equation gives us du dx equals, and then the derivative of sine is cosine of y, but then we have to multiply by the derivative of this part because that's our chain rule, so it's going to times the derivative of y dx. We then took cosine of y to the other side of our equation by dividing it. It gives us du dx divided by cosine of y. And we're going to take that same Pythagorean identity from before and apply it a little differently. This time we're going to solve for cosine of y. So we subtracted sine squared to the other side, and then take the square root, which gives us cosine of y is equal to the square root of 1 minus sine squared of y. And we can now replace cosine of y with this radical here. And we know that the sine of y from up here is equal to u. Therefore, our final formula becomes dy dx equals the derivative of u over the square root of 1 minus u squared. All right, so now that we have our derivatives, let's go ahead and see if we can get some take some derivatives of our trig functions here. All right, so the first one we have is y equals sine of 4x squared. And so the derivative of sine is cosine. The inside part stays the same, but then we multiply by the derivative of the inside part, which will give us 8x. And putting things in order, we usually would write this as 8x cosine of 4x squared. That would be our derivative. Remember that this is your chain rule part. You always must remember to apply the chain rule, which is multiplying by the derivative of the inside part, which is what is inside our parentheses here. So the next problem, we do have multiplication in between here, so this makes this a product rule. So you're going to have the first times the derivative of the second, which will give us negative sine 5x times chain rule times the derivative of the inside part. So there is first times derivative of the second plus second times derivative of the first, which would be cosine of 2x, and then times 2. So cleaning this up a little bit, you would end up with negative 5 sine 2x sine 5x, and those cannot be combined together because what's in the parentheses is not the same. If they were the same, then you could say sine squared of whatever it is. All right, so then we're going to have plus 2 cosine 5x cosine of 2x, and that is our final version of our answer here. All right, next problem, we're going to be applying quotient rule. So quotient rule is going to give us bottom times the derivative of the top, which will be secant 2x tangent 2x times the derivative of 2x, which is 2. So there's bottom times derivative of the top minus top times derivative of the bottom. And derivative of tangent is secant squared 2x times the derivative of 2x, which is 2. All of this is over bottom squared. All right, so just to clean this up a bit, this would give you 2 secant 2x. We have a tangent 2x times a tangent 2x, so that would give us tangent squared 2x minus, and then we would have secant cubed 2x, and this is all over tangent squared 2x. All right, so now a derivative of an inverse trig function. So the derivative of tangent inverse of u is du dx over 1 plus u squared. So here in this situation, our u value is sine of x, which means du is equal to cosine of x. All right, so applying our formula here, we've got du dx, which is cosine x, over 1 plus u, which is sine squared, which can also be written as cosine x over 1 plus sine squared x. Just another version of the same answer. And then this one is I just wrote it differently so that you get a little bit of exposure. Remember that arc sine means the same thing as sine inverse. And so what we're going to have here then is our u value is 3x plus 1, which means du is equal to 3. And our derivative for sine inverse is du dx over the square root of 1 minus u squared. So we're going to have du dx, which is 3, over the square root of 1 minus 3x plus 1 squared. And we're done. You just really need to know your formulas for your inverse trig functions, and then it's just a matter of a simple derivative and plugging in your u values. Now, anytime you see something like sine squared or sine to the fourth power of x or anything like that, one of the ways you can interpret this is as sine of x in parentheses being squared. This means exactly the same thing, which means we need to apply the power rule to this. Power rule says we will bring that exponent to the front and then reduce it by 1, so it becomes to the first power. Inside part stays the same. Then you have to multiply by the derivative of the inside part, which would be times cosine x. So your cleaned up version would be 2 sine x cosine x for your answer. You always need to remember to multiply by your chain rule, the derivative of the inside part. And pretty much anytime you've got this exponent here and you're taking a derivative of a trig function that's raised to a power, you need to apply that power rule along with chain rule on that. All right, so let's take a look at the next problem. This time it's not cosecant that's being raised to the second power. It's just this x that is being raised to the second power. So again, we will have chain rule here, but it's going to be applied to the x squared, not to the cosecant. So the derivative of cosecant is negative 5 cosecant x squared cotangent of x squared, and then we multiply by the derivative of the inside part, which is 2x. Cleaned up, this would be negative 10x cosecant x squared cotangent of x squared. All right, so now it is time for you to apply some of these things that you've learned in this video and practice on your classwork assignment.